Greetings. In this video, I'm going to be demonstrating how to do number conversions with decimal to binary, hexadecimal to binary, octal to binary, and vice versa. So for my first demonstration, I'm going to be doing binary to decimal. So to begin our binary to decimal number conversion, we want to start with our binary to decimal table, in which we're going to draw 10 columns and 3 rows. So after we're done drawing our table, we're going to start off by inserting our square roots, what they're equal to, and then we're going to write the binary number. 2 square root of 0 is equal to 1. 2 square root 1 is equal to 2. 2 square root 2 is 4. 2 square root 3 is 8. 2 square root 4 is 16. 2 square root 5 is 32. 2 square root 6 is 64. 2 square root 7 is 128. 2 square root 8 is 256. And 2 square root 9 is 512. So when we write our binary number, we want to insert the binary number in the last row. So for my binary number, I chose 1, 1, 0, 0, 1, 0, 1, 1, 0, 0. And basically after we're done writing our binary number in the boxes, we want to add all of the boxes that have a 1 in them. So I'm just going to draw an arrow down just to indicate which ones I will be adding. So we see that I'll be adding 512 plus 256 plus 32 plus 8 and plus 4. Once we add them all together, we're going to get 812. Our decimal number is 812. Okay, so next we're going to do decimal to binary. And decimal to binary is a bit different. So for decimal to binary, we're going to take 812 and divide it by 2. Every time we divide by 2 and there's a number left over, we're going to keep the remainder of each number. If there is no remainder of the number once it's divided by 2, we're going to say that it's 0. So for 812, we're going to start at 812 divided by 2, which is equal to 406, with the remainder of 0. 406 divided by 2 equals 203, remainder of 0. 203 divided by 2 equals 101, remainder of 1. So 101 divided by 2 equals 50, remainder 1. Then we have 50 divided by 2 equals 25, remainder 0. Then we're going to say 25 divided by 2 equals 12, remainder 1. So 12 divided by 2 equals 6, remainder 0. And then 6 divided by 2 equals 3, remainder 0. Then 3 divided by 2 equals 1, remainder 1. And then 1 divided by 2 equals 0, remainder 1. So when we look at this number, we're going to say that the number at the bottom is the most significant and the number at the top is the least significant, meaning that we're going to start writing our decimal to binary number from what we see at the bottom. So all of the remainders are going to turn out to be our binary numbers. So starting from the bottom, 1, 1, 0, 0, 1, 0, 1, 100, which is the same as our number right here. So that is how you convert binary to decimal and decimal to binary. For the next section, we're going to do a binary to hexadecimal conversion. We have our hexadecimal table already pre-drawn, and we're going to create a binary number. So to create a binary number, we're going to have 4 place values. So I'm just going to create one once again. 1001, 1101, 1011, and 1010. When we write our hexadecimal number out, we want to divide it into 4. Divide every 4 numbers. So once we divided all of our binary numbers into hex sections, which is values of 4, after we do that, we're going to look at our hexadecimal table and just write down the numbers that match the binary. So 1001 would be written as 9. 1101 would be written as D. 1011 would be written as B, and 1010 would be written as A. So our binary to hexadecimal number would be 9DBA. So if we look at 9, we see that. So if we take our hexadecimal number and convert it back, we're going to look at where 9 is and put 1001. Look at where D is, put 1101. Where B is 1011, and where A is 1010, and that is our binary number. That's how we convert hexadecimal to binary. For this next demonstration, I'm going to be doing binary to octal, and I already have my octal table drawn out. So we're going to start by creating a binary number. 110, 101, 110, 001. And so once we have our binary number created, we want to divide it up into 3s. So 110, then we want to draw a line. 101, draw another line. 110, draw another line. So this tells us that we're going to have 4 numbers. So for this first number, it's going to be 110. When we look at our octal table, we can see that this is 6. 101, we see on the table that this is 5. 110, again, which is 6, and 001, which is 1. So our binary to octal number would be 6561. So octal to binary, we would just take a number, let's say 6561 once again. Then we would just look at our octal table, in which 110, if we look at 6, we'll write 110. We look at the number 5 with 101 next to it, that's what we'll write. 6 again, which is 110, and then 1, which is 001. And that's how we find our octal to binary conversion.